So I wanted to go over the information we talked about in section 3.4 and 3.5, where we were talking about solving, quadratic equations. We talked about two different methods to use when we were solving. We focused on factoring. When we're factoring, remember our equation has to equal 0 before we begin factoring. We want our factors to become linear factors, and once we have it factored, we will set each of those factors equal to 0 to find our different solutions. The other method we talked about was our square root method. For the square root method, we want the squared quantity by itself. We want it to equal our constant value. We will take the square root of both sides to solve. When we do, we need the positive root and the negative root of the constant value. And then sometimes we'll have to do a little bit more work to solve for our variable. Other times we won't. It'll just vary problem by problem. So those are the two methods I wanted us to look at examples of. So here, these problems are not factored. When I look at these equations, they are not binomials. They are trinomials or four-term polynomials. Those are all hints that we might want to solve using factoring. So here, if I was going to solve by factoring this particular equation, it's not set equal to 0 right now, so I'm going to go ahead and add 14 to both sides of the equation so that it will equal 0. So we have 2x squared minus 18x. These cancel, so equals. These also cancel, so we can go ahead and put 0 over there on the other side. Now we have this two-term polynomial. It's not just a squared quantity. I still have an x as well, so I can't really use the square root method here. I'm going to continue to try factor. This one I can use a greatest common factor. These both divide by 2x. So I'm going to have my 2x, and that's going to leave me with x minus 9, whole thing equal to 0. Now I have it factored into two linear factors, so I'll set one of them equal to 0 and solve, which is going to give me x equal to 0. I'll have the other one and set that equal to 0 and solve, and that gives me my other solution. This is fine if you leave it like this on paper. In Alex, you'll be entering these numbers into the open set that the problem has already started for you. So you would type in 0, 9. So that would be our answer to this particular problem. Here on this one, it is already equal to 0. We need to factor. It is a trinomial, but when we look at that trinomial, it's not a second degree trinomial, it's a third degree trinomial, which generally means there is a greatest common factor. These all divide by x, so let's take that out of the problem first. When we do, we're left with x squared plus 4x minus 21 equal to 0. To factor this trinomial, we need two numbers that have a product of 21 and a sum of 4. Negative 21, don't lose the negative. That would have to be, what, 7 and negative 3? 7 times negative 3 equals negative 21. 7 plus negative 3 equals 4. This, because it has that nice leading coefficient of 1, means we can go directly to our factors. So we will have x plus 7, x minus 3, whole thing equal to 0. Now that it's factored, we will set each factor equal to 0 to get our solutions. So this factor gives me x equal to 0 because there was no plus or minus to it. That's one solution. X plus 7 equals 0. That's going to give us x equal to negative 7. And then x minus 3 equal to 0 will give us x equal to 3. So these would be our three solutions to this particular problem. Here on this one, 6x squared plus 5x equals 25, not equal to 0, so we need to start by moving that 25 over first. That gives us 6x squared plus 5x minus 25, whole thing equal to 0. We want to solve this by factoring. So 6 and negative 25 gives me a product of negative 150. And we want a sum of 5. We started by taking 6, and it would be negative 6 and 25. Those do not give me 5, though, unfortunately. 150 does end in 0, which means it should divide by 10. When I do that, I get 15. So I could do 15 and negative 10. Those multiply to negative 150, and they add up to 5. So I can use that. I'm going to use that, remember, to split up that middle term. So I'm going to have 6x squared plus 15x minus 10x minus 25 equal to 0. These first two divide by 3x. That's going to give us 2x plus 5. These next two have a common factor of 5, but I'm also going to take out the negative. So their GCF is negative 5. Again, gives us 2x plus 5. That means we're going to get 2x plus 5 and 3x minus 5 equal to 0. Now that we have it factored, we need to go ahead and set each factor equal to 0. 2x plus 5 equals 0. We would have to subtract 5 to get 2x equals negative 5 and divide by 2 to get negative 5 over 2. And then for the 3x minus 5, we would have to add 5. So 3x equals 5, divide by 3. So that would give us 5 over 3. So those would be our two solutions, negative 5 over 2 and positive 5 over 3. Here on this one, we have x cubed plus 9x squared minus 4x minus 36 equals 0. This one is a 4-term polynomial. We should go ahead and factor by grouping. This gives us x squared, which will then give me x plus 9. This one, they both divide by negative 4. So I have a negative 4. That's going to give me x plus 9 as well. That means we're going to have x squared minus 4 and x plus 9 equal to 0. This is factored. This factor is linear, but this one is not. If it's not a linear factor, we should go ahead and try to factor further. X squared minus 4 is a difference of squares, so it should factor into a conjugate pair. So it will factor into x minus 2 times x plus 2. And then we have the x plus 9 that we had from the original factoring, whole thing equal to 0. Now all of my factors are linear factors. They're all going to give me a solution. So I would take them and set them equal to 0. This one gives me 2. The next one is going to give me negative 2. And then we will get negative 9. So those are our 3 solutions to this particular problem. Here, this one is already factored. Some of the factors have these exponents attached to them on the outside of the parentheses. That doesn't change the fact that inside of the parentheses, what I have is a linear quantity. So I can ignore these for right now and just focus on the factors that I've been given to solve this equation. Do not recombine them. That doesn't help us solve. So I have 4x equal to 0, which gives me a solution of x equal to 0. I have x plus 2 equal to 0, which gives me a solution of negative 2. And x minus 5 equal to 0, which gives me a solution of 5. And that's all I would have to do with that one. So these are actually easier. I don't have to do the factoring. It's already been done for me. One more like that. I have negative 2, 3x plus 5, x minus 4 squared. Again, the quantities inside are linear, which is what I'm going to focus on. If I take that first factor of negative 2 and set it equal to 0, there's no variable there. There's no x with that. So it's not going to give me a solution. So I'm just going to not get anything from that one. 3x plus 5 equals 0. I'm going to subtract 5. So I'll get 3x equals negative 5. I'll divide by 3 to get negative 5 over 3. And that last factor should give us x equal to 4. So we get these 2 solutions out of that particular problem. So that was us solving by factoring. These others are going to be us trying to solve using our square root method. Here, when I look at this equation, x squared plus 18, it does not factor. It's not a difference of squares, so it can't really solve it by factoring. We said when we're solving using the square root method, we want the squared quantity alone, which means I want that 18 to go to the other side. So I'm going to subtract 18 from both sides. That's going to give us x squared is equal to negative 18. Now that the squared quantity is alone, I will take the square root of both sides. That turns that x squared into an x. Square root of negative 18, we have negative 1. 18 is what, 9 and 2? So I can rewrite that negative 18 as negative 1, 9, and 2. This is going to give us the I we talked about earlier. This is going to give us a 3, and that root 2 is going to stay a root 2. So we're going to get 3i square root of 2. Remember, not only the positive square root, but the negative square root as well. So negative 3i square root of 2. We also talked about how we could use that plus or minus symbol, both on paper and online, to represent both answers. Because this just means we have positive 3i root 2 and we have negative 3i root 2. Those both mean the same thing for format-wise. So either this or this, those are both good answers. This next one, 6x squared is equal to negative 48. We want the squared quantity to be alone, so I'm going to divide by 6 because I don't want that x squared to have anything attached to it if I can avoid it. So 48 divided by 6 is going to give us 8. So we have x squared is equal to negative 8. Now that we have our x squared completely alone, we will take the square root of both sides. That will turn into x is equal to the square root of negative 8, which we can rewrite as negative 1, positive 4, and 2. So that's going to become 2i root 2. Not just the positive root, but also the negative root, so negative 2i root 2. We could also, again, do the shorthand plus or minus 2i square root of 2. So those would be our solutions. Even though they're not real, we can still represent the solutions. Here we have 2x squared equal to 50. Again, we would like our x squared to be alone, so I would go ahead and divide by 2 first. That turns this into x squared equal to 25. Now that I have my squared value alone, I'm going to take the square root of both sides. So x is equal to 5, not just the primary root, but that secondary negative root as well. So also negative 5. And so those are our two solutions to this problem. Let's say we have something like this. X plus 3 squared is equal to 16. Here, my squared quantity is not just an x, but that's okay. The quantity itself is already alone, and the constant is on the other side, which means I can go ahead and take the square root of both sides first. That's going to give us x plus 3 equal to plus and minus 4. Here, when I have something like this, I do need to separate this out into two separate things so that I can find my two separate solutions. So I have x plus 3 equal to positive 4, and I have x plus 3 equal to negative 4. We're going to solve both of those to get our solutions. On this first one, we would have to subtract 3 from both sides, which should give us a solution of x equal to 1. On the second one, also subtracting 3 from both sides, and that gives us negative 7. So our two answers will be 1 and negative 7 on this problem. Here on this one, x minus 1 squared is equal to negative 4. Again, our squared quantity is already alone and equal to a constant, so I'm going to take the square root of both sides to solve. That's going to give me x minus 1 is equal to, this becomes what, 2i because of the negative, and it is that plus and minus 2i. Again, we're trying to solve for x, so we have a couple of options here. We're not going to be able to add the 1 and that 2i anyways because they're not the same type of number. The 1 is real, the 2i is not. So one thing we could do is just move that 1 over here, and that would give us 1 plus or minus 2i. This is perfectly fine. Or you could write it out like we did the other one. X minus 1 equals 2i, x minus 1 equals negative 2i, and solve for x. It's still going to give me 1 plus 2i and 1 minus 2i. It's just written out as two separate numbers. instead of this shorthand. We can leave it in the shorthand because we're not able to combine the 1 and the 2i. Whereas over here on this problem, if we had tried to leave it as, say, x equals -3 plus or minus 4, because -3 and 4 are numbers we can combine, we can't leave it this way. We actually have to combine them by adding or subtracting them to get their overall integer values of 1 and -7. But here, since we can't combine them, we could just leave it and it would be fine. One more, x plus 5 quantity squared is equal to 20. Again, we would have to take the square root of both sides. 20 is what, 4 and 5? So we're going to have x plus 5 equal to 2 square root of 5, both positive 2 root 5 and negative 2 root 5. Again, here we have to solve for x. We're going to have to move that 5 over to do it. We're not going to be able to combine the 5 and the 2 root 5 because, again, they're two different types of numbers. So if we wanted, we could just write x is equal to -5 plus or minus 2 root 5. That would be perfectly fine. Or you could split it like we did earlier and set it equal to 2 root 5 and -2 root 5, and then solve for x. So we would get -5 plus 2 root 5 and -5 minus 2 root 5. Both of these are good ways of writing the answer. It's just personal preference at this point, okay? So I hope that makes sense. Please let me know if you have any questions about solving quadratics, either using factoring or the square root method.